Around 26,500 years ago, the Earth looked almost nothing like the planet you live on today. Temperatures across much of the northern hemisphere had dropped roughly 6 to 10 degrees Celsius below modern averages. Ice sheets more than 2 miles thick blanketed everything from what is now Canada down to New York. Glaciers covered northern Europe as far south as the Thames Valley. This wasn't a brief cold snap or a rough winter. This was the last glacial maximum, the deepest and most severe phase of an ice age that had been grinding on for tens of thousands of years, reshaping coastlines, locking up so much of the planet's water in ice that global sea levels ran approximately 125 meters lower than they do right now. And scattered across this frozen, dramatically inhospitable version of Earth, there were humans. But they were there, and somehow they didn't die. So how did they actually do it? The answer involves a genuinely impressive combination of biological adaptation, behavioral flexibility, technological ingenuity, a level of ecological knowledge so detailed and precise that it took modern science several centuries of careful archaeology to even begin reconstructing it properly. This was because what those populations managed to accomplish, in conditions that would kill most modern humans within days without external support, represents one of the most significant survival achievements in the entire history of the species. Let's start with the environment itself. At the last glacial maximum, the Laurentide ice sheet covering North America contained roughly 26 million cubic kilometers of ice. The Fennoscandian ice sheet covering northern Europe was smaller but still massive enough to depress the crust of the Earth itself, several hundred meters under its own weight. In Asia, the situation was somewhat different. The Siberian interior, paradoxically, wasn't fully glaciated because the climate was too dry to produce enough snowfall to build ice sheets. But it was bitterly cold, an open, treeless steppe stretching for thousands of kilometers under skies that saw almost no precipitation. Global vegetation zones had shifted dramatically southward. Forests retreated, savannas contracted. The zones capable of supporting dense plant and animal life shrank to refugia, isolated pockets where the conditions remained tolerable enough for ecosystems to persist. The humans living through this weren't modern people in ancient body. They were anatomically modern Homo sapiens, with the same cognitive hardware you're using right now to watch this video. The same capacity for language, abstract reasoning, long-term planning, and cultural transmission. They didn't have less mental capacity. They had less accumulated knowledge to draw on, fewer tools, no written records, no ability to import resources from thousands of miles away. What they did have was the same flexible, creative, problem-solving brain that eventually produced everything from the wheel to the smartphone, applied with extraordinary urgency to the immediate problem of staying alive in one of the coldest periods in the last several million years. The most pressing survival challenge wasn't shelter or clothing, though both mattered enormously. It was calories. In a glacial environment, the human body burns significantly more energy maintaining core temperature than it does in temperate conditions. That means the caloric demand placed on Ice Age populations was substantially higher than what modern people living in heated homes require. Estimates from researchers studying present-day populations living in cold, high-latitude environments suggest that sustained cold exposure can increase daily caloric needs by anywhere from 25 to 50% above baseline. For a small band of hunter-gatherers already operating on the margins of what their landscape could provide, that kind of additional demand wasn't a minor inconvenience. It was an existential constraint that shaped every decision about where to camp, where to hunt, how long to stay anywhere before moving on. Large game was the primary solution. Pleistocene megafauna provided it on a scale that's hard to fully appreciate from a modern perspective. The landscapes of Ice Age Europe and Asia were populated by animals that no longer exist anywhere on Earth. Woolly mammoths standing more than 3 meters at the shoulder, woolly rhinoceroses, cave lions, giant deer with antler spans exceeding 3 meters, vast herds of horses, reindeer, bison, aurochs moving across the periglacial steppe in numbers comparable to the great ungulate migrations of the modern Serengeti. A single woolly mammoth, if successfully hunted and butchered, could provide a band of 30 people with several hundred kilograms of meat, fat, bone marrow, hide, bone, ivory all at once. The fat content of a mammoth carcass was particularly critical because fat, not protein, is what allows the human body to sustain itself through long, cold winters without metabolic collapse. Hunting these animals, however, required cooperation, planning, technology at a level that went well beyond simply throwing a rock at something large. Archaeological sites from this period in places like Dolní Věstonice in the Czech Republic and Sungir in Russia show clear evidence of coordinated group hunting strategies. including the use of natural terrain features like cliffs, ravines, river crossings to funnel and trap large animals in positions where relatively small groups of hunters could overwhelm them. Spears tipped with carefully knapped stone points, bone or ivory were the primary weapons, but some sites show evidence of atlatels, spear-throwing devices that effectively extended the human arm and could launch a projectile with enough force and velocity to punch through the thick hide of a mammoth or woolly rhinoceros. The technology was deliberately designed, refined over generations, passed down through cultural transmission rather than reinvention, every generation from scratch. Fire was arguably the single most important technology those populations possessed, not primarily for the reasons most people assume. Yes, fire provided warmth. Yes, it kept predators away. Ice Age Europe had no shortage of large carnivores that actively competed with humans for the same prey. Cave lions, hyenas, and wolves all represented genuine threats, but cooking was the transformative function of fire that most directly enabled survival at high latitudes. Raw meat and raw tubers provide far fewer usable calories than the same foods cooked. This was because heat breaks down cellular structures and proteins in ways that the human digestive system can then process far more efficiently. Populations with reliable access to fire could extract substantially more energy from the same quantity of food than populations without it. Shelter construction in the open periglacial steppe of Central and Eastern Europe represents one of the more remarkable engineering achievements of the Paleolithic. In regions where cave systems weren't available and the landscape offered no natural rock overhangs, Ice Age populations built structures using the bones of the very animals they hunted. Excavations at sites across Ukraine and Russia have uncovered the remains of structures where mammoth skulls, long bones, jawbones were arranged in interlocking patterns to create dome-shaped frameworks, almost certainly covered with hides and insulating material. Some of these structures were substantial enough to have housed multiple families simultaneously. The presence of central hearths in many of them confirms that heat management was a primary architectural concern. Clothing deserves more credit in this story than it typically receives. The invention of tailored, fitted clothing made from animal hides is genuinely one of the most consequential technological developments of the Ice Age. Its importance goes considerably beyond simple comfort. There is a meaningful physiological difference between draping an untailored hide loosely over your body and wearing garments that are cut, sewn, fitted to seal body heat efficiently around your limbs and torso. Genetic evidence from body lice, that evolved specifically to live in clothing rather than hair, suggests that tailored clothing appeared somewhere between 83,000 and 170,000 years ago, meaning humans had been refining textile technology for tens of thousands of years before the last glacial maximum arrived. By 26,000 years ago, the population surviving deepest cold had multi-layered garment systems, boots, headwear sophisticated enough to maintain survivable body temperatures during prolonged exposure to conditions well below -30 degrees Celsius. The management of plant resources during Ice Age winters was considerably more nuanced than it might appear at first glance. Most people assume that plant food essentially vanished from high-latitude diets during glacial periods. While it's true that the diversity and abundance of edible plants dropped dramatically compared to warmer climates, it didn't disappear entirely. Evidence from dental calculus, that is the hardened plaque that forms on teeth and preserves microscopic traces of everything a person ate, has revealed starch granules and plant fibers in the teeth of individuals from some of the coldest Paleolithic sites. Roots, rhizomes, and certain seeds remained available under snow if you knew exactly where to look and when to dig. Knowing where to look was itself a form of accumulated cultural knowledge passed down through generations, a kind of ecological database stored in human memory and transmitted through teaching rather than through writing. Population structure during the last glacial maximum tells its own story about how survival actually worked at the scale of the entire species. Genetic studies analyzing ancient DNA from skeletal remains across this period consistently reveal dramatic reductions in effective population size, a phenomenon called the population bottleneck, during which the total number of breeding individuals fell to levels that today would qualify a species for endangered status. Estimates vary, but some analyses suggest that the effective breeding population of modern humans globally during the most severe phases of the last glacial maximum may have been as low as several thousand individuals clustered in geographically scattered refugia. The small populations that made it through did so by retreating into specific geographic zones where conditions remained tolerable enough to sustain life. These refugia were concentrated in particular regions where a combination of latitude, ocean proximity, terrain kept temperatures slightly less lethal than the continental interiors. Southern France and northern Spain hosted one of the most significant European refugia, sheltered by the Pyrenees and the Atlantic's moderating influence. The Iberian Peninsula further south remained ice-free and relatively productive throughout the worst of the glacial maximum. In Asia, populations clustered along coastal zones and river valleys where marine and riverine food resources supplemented terrestrial hunting. The southern coast of Asia, much of which is now submerged beneath higher post-glacial sea levels, likely supported significant populations throughout this period. Recent genetic studies suggest that coastal migration routes along what was then a much more extensive landmass may have been as important as the more commonly discussed inland routes for understanding how human populations moved and survived during this era. The Beringian land bridge deserves particular attention in this context, both for what it was and for how extraordinarily well adapted the populations crossing it must have been. During the last glacial maximum, the lowered sea level exposed a landmass called Beringia, connecting what is now Siberia to what is now Alaska, a region roughly the size of modern Australia that sat at the edge of the habitable world. The people who eventually moved across it and into the Americas weren't stumbling accidentally into a new continent. They were populations that had already spent generations adapting to the extreme cold of northeastern Siberia, arguably the harshest inhabited environment on the Pleistocene planet, then extended their range eastward across Beringia into a genuinely new and previously uninhabited landmass. The genetic signature of this crossing is still visible in the DNA of all indigenous American populations today. Descended from a founding group whose ancestors survived the Ice Age in conditions that should, by any reasonable assessment, have been unsurvivable. Social organization was a survival technology in the same sense that spears and fire were survival technology. The evidence from Ice Age archaeological sites consistently points toward groups that were neither isolated family units nor enormous undifferentiated bands. The pattern that emerges is something closer to a network of smaller residential groups, probably numbering between 20 and 50 individuals each, connected through regular interaction, intermarriage, resource sharing with neighboring groups across larger regional territories. This structure mattered enormously for survival because it created a kind of distributed risk management. When one group's local hunting territory failed to produce enough food in a given season, access to the territory and resources of neighboring allied groups could prevent starvation. Without that network, any single group facing a bad season with no external support had a meaningful probability of not surviving it. The extraordinary art produced during the last glacial maximum has sometimes been treated as a side note in discussions of Ice Age survival, as though the people who painted Lascaux or carved the Lion Man of Hohenstein-Stadel were taking a brief break from the serious business of staying alive. This framing misses something important. The cognitive and communicative capacities required to produce symbolic art are the same capacities that enabled the complex planning, social coordination, information storage that made survival possible. The same brain that could visualize a bison on a cave wall in enough detail to render it in pigment by firelight was also the brain managing seasonal migration routes, memorizing the behavioral patterns of prey animals, coordinating multi-person hunts, transmitting critical ecological knowledge across generations. The art wasn't separate from the survival strategy. It was produced by the same cognitive system that made the survival strategy possible. Information storage and transmission across generations represented a critical survival infrastructure in its own right. In the absence of writing, everything Ice Age populations needed to know in order to survive, every migration route, every seasonal resource location, every hunting technique, every method for processing hides, every medicinal plant, every construction technique, had to be encoded in human memory and transmitted through teaching, storytelling, and demonstration. This created enormous selective pressure favoring not just intelligence in the abstract sense, but specifically the social and communicative intelligence required to teach accurately and learn efficiently. Researchers studying traditional ecological knowledge in contemporary hunter-gatherer populations have documented the extraordinary depth and precision of this kind of transmitted environmental knowledge. There's no reason to assume Ice Age populations were working with anything less comprehensive. The relationship between Ice Age populations and the megafauna they depended on for survival was not indefinitely stable. This instability ultimately mattered for how the Ice Age ended, at least from the perspective of human populations, between roughly 50,000 and 10,000 years ago, depending on the continent. The great Pleistocene megafauna went extinct almost everywhere that modern humans arrived. The causes are genuinely debated among researchers, with some emphasizing human hunting pressure, others emphasizing climate change at the end of the glacial period. Most current thinking landing somewhere in the interaction between the two. What's less debated is the consequence, as the large mammals that had provided the bulk of dietary calories in high-latitude environments disappeared. Human populations faced a forced restructuring of their entire subsistence strategy. A transition from large game specialization toward broader spectrum foraging that eventually contributed to the conditions enabling the development of agriculture. The Younger Dryas, a rapid return to near glacial temperatures that struck approximately 12,900 years ago and lasted about 1,200 years, represents one of the most dramatic climatic reversals in the post-glacial record. Its effects on human populations were correspondingly dramatic. Temperatures in parts of Europe dropped by as much as 15 degrees Celsius within a span of decades, not millennia. Vegetation zones collapsed southward again. Populations that had been expanding northward as glaciers retreated were suddenly facing conditions almost as severe as the last glacial maximum. But now without the megafauna populations that had supported their ancestors through the earlier cold. The populations that survived the Younger Dryas drew heavily on the accumulated survival knowledge of previous generations, while adapting it to a landscape that had fundamentally changed in the 1,000 years since the deepest cold. Coastal and marine environments played a larger role in Ice Age survival than the archaeological record initially suggested. This is partly because the most productive coastal sites from that period are now submerged. When sea levels were 125 meters lower than they are today, the richest coastal habitats, the tidal zones, estuaries, shallow marine shelves where seafood is most concentrated and most accessible, were located where there is now open ocean. The populations living on those coastlines have left evidence only where it happens to survive above current sea level or in underwater archaeological sites that are extraordinarily difficult and expensive to excavate. What evidence does survive, including shell middens, fish bones, marine mammal remains at sites from southern Africa to coastal Europe and Asia, consistently shows that marine resources were intensively exploited wherever they were available, and that coastal populations using these resources maintain higher and more stable population densities than comparable groups relying solely on terrestrial hunting. The transition out of the last glacial maximum, that began in earnest around 19,000 years ago and took several thousand years to complete, wasn't simply a story of climate warming making everything easier. For populations whose entire knowledge base, technology, social organization, territorial relationships had been calibrated to glacial conditions, the warming created new challenges even as it removed old ones. Forests expanding northward across previously open steppe changed the hunting strategies that worked. New plant species appearing in previously glaciated areas required new knowledge to identify and safely exploit. Coastlines shifting as sea levels rose displaced populations that had built their lives around specific geographical features that were now underwater. The populations that navigated this transition most successfully were almost certainly those with the greatest behavioral flexibility, the broadest ecological knowledge base, the most robust social networks for sharing information about rapidly changing conditions. By around 11,700 years ago, when the Holocene epoch officially began and the climate stabilized into something resembling the world we live in today, the human populations that had survived the Ice Age were scattered across virtually every habitable continent on Earth except Antarctica. They had crossed land bridges, survived population bottlenecks that reduced their ancestors to a few thousand individuals, outlasted multiple glacial advances and retreats, adapted their technologies and subsistence strategies repeatedly in response to conditions that changed faster than any single human lifetime could track, preserved enough accumulated knowledge across generations to begin, within the next few thousand years, independently inventing agriculture in at least 7 different locations across the globe. The transition to farming didn't come out of nowhere. It was built on a foundation of ecological knowledge, social complexity, behavioral flexibility that tens of thousands of years of Ice Age survival had selected for and refined. The earliest domesticated crops appear in the archaeological record beginning around 10,000 to 1100 years ago in the Fertile Crescent, with independent origins following in China, Mesoamerica, the Andes, New Guinea, the Sahel, Eastern North America over the subsequent several thousand years. Each of those independent inventions drew on pre-existing knowledge of plant behavior, growth cycles, ecological relationships that had been accumulating in human populations since long before the last glacial maximum. The people who first began intentionally cultivating wild cereals in the Levant weren't starting from zero. They were applying a deep archive of botanical knowledge to a new strategy, one that happened to be made possible by the stable, predictable climate of the post-glacial world, a climate that their ancestors had helped make it to the other side of through a combination of ingenuity, cooperation, a remarkable refusal to stop adapting.